Hello everyone. Today we're going to focus on writing equations of exponentials from graphs. Before we move on to graphs, we really want to make sure that we feel comfortable with tables since graphs are going to feel extremely similar. So, for our warm-up today, we're going to try to write the equation represented in this table. So I'm going to give you a moment. Go ahead, pause the video, and come back when you're ready. Okay, so we know that the structure of an exponential function will always be the same for algebra 1 and really onwards, but we focus on not as many transformations as you will see in algebra 2. So we know we can find our base because it's our common multiplier, meaning I'm multiplying 8 by something to get 2, and I'm multiplying 2 by something to get b. Some people are going to feel really comfortable immediately finding that, and some people aren't. So it's totally up to you on the structure that you use. One thing I'd like to pay attention to is that those numbers are getting closer to our horizontal asymptote of 0. And since those numbers are getting closer to 0, I know that this has to be a decay. So I like making a little note to myself, which means my base has to be less than 1. Okay. So if we have a hard time figuring out what that value actually is, we can set up an equation. I know 8 times some kind of number is going to give me 2. Then when I solve for b, I'm going to divide both sides by 8, and I get b equals 2/8. Well, when I do that and I reduce it, I know that my base is 1/4. So now I know my base is 1/4. I can go and substitute that in. Y equals a 1/4 to the x. Now, in order to find my a, just like with our quadratics, I'd substitute in a value for x and y. You can use any point you want as long as you know it's on the function. So I'm going to choose the point -1, 2. But again, it doesn't matter. So -1, 2. -1 is my x, 2 is my y. And I'm just going to substitute those in. So 2 equals a 1/4 to the -1. Now I know from my exponential properties that anything with a negative exponent, we have to switch to the other side. So numerators become denominators, denominators become numerators. Also thinking of that as the reciprocal. And since I know if I take the reciprocal of that, I get 4. Anytime I write a number times a variable, we always put that in front. So I'm just going to model that here. And then divide both sides by 4. And I find that my a value is 1/2, meaning this exponential function was shrunk by 1/2. So y equals 1/2, the base of 1/4 to the x. And that's my final answer. Okay. So now we're going to do the exact same thing, but with a graph. So if I look at this graph, the first thing I like to do still, I know my structure is y equals a times b to the x. I like to figure out, is this a growth or a decay? So if I look at this function from left to right, that is getting closer to the horizontal asymptote, so I know it's a decay. So I'm still, just like our warm-up, I'm expecting that base to be less than 1. And then just to help myself structure, I actually take my points and make a table, which is why I said we really want to make sure we feel comfortable with tables. The key here is when you write your points down, make sure you're going from left to right. So your x values should always start with the smallest and go to the largest. And then we literally repeat the same process. So I know my base, I'm trying to figure out what do I multiply by 10 to get 2? 2 times what is 0.08. We can set up an equation if we can't see it. 10 times b equals 2. Divide both sides by 10. And then if I reduce, I have 1/5 as my base, which checks out because that's less than 1. A lot of people, the most common mistake is they see 10 and 2, and we automatically, our brains think, oh, that's times 5, and we make that our base. If our base was 5, this function would be increasing, going further away from our horizontal asymptote. So use that comment, that kind of double checking yourself to make sure that you're not making a small mistake. That's actually a huge mistake. So I'm going to substitute that in. And then just like our other one, when I'm trying to find my a value, I'm going to choose a point. And for this one, I'm going to stick with 0, 10. Remember, it doesn't matter which one you do. So 0, 10. My x is 0 and my y is 10, so I'm going to substitute those in to solve. Okay, I also remember from my exponential properties that anything to the power of 0 is a 1. So I have 1 times a, which means a equals 10. And then I'm ready to put it all together. So y equals a times b to the x. And that's my final answer. Okay, one more problem together, and then I'm going to have you try one. So problem number 2, first thing I like to do, same idea, left to right, that's growing away from the horizontal asymptote, so I know it's a growth. If it's a growth, my base has to be greater than 1. So I'm going to do the same process as before. I'm going to make my table, always making sure to start left to right. So my leftmost point that I can actually see, we don't want to assume any points, is 0, 1/4, then 1 and 1/2, and then 2 and 1. So when I'm finding my base, I have to figure out what am I multiplying by each time. Again, some of us are going to feel comfortable with it, some of us aren't, and that's okay. I'm going to set up an equation. So 1/2 times some number b equals 1. 1/2 times some number b gives me 1. Okay. If I divide by 1/2, that's one option you have. But remember, dividing by dividing by a fraction is the same thing as multiplying by its reciprocal. And the reciprocal there is 2 over 1. So 1 times 2, 2. And now I'm going to substitute that into my equation. So y equals a times b to the x. And then same process. I'm going to choose a point. We usually like dealing with whole numbers, so I'm going to choose that 2, 1. If my iPad lets me. So 2, 1, x and y. I'm just going to take those and substitute them in. So 1 equals a 2 to the second power. And that's just me taking my x and putting it where I see x, y putting it where I see y. Okay, exponents first, so 2 squared is 4. And then I'm going to divide 4 by both sides. So a equals 1/4, which means my function was shrunk by 1/4. We want to be careful not thinking that that a value tells us anything about growth or decay. It doesn't. That's our base, which is a number being raised to an exponent. That 1/4 is just a stretch, shrink, or reflection. Okay. And then you could try the last one.